Good morning! It is still morning, just. Okay, right, I'm just getting myself sorted and set up. You've got a question on the screen you might want to look at, something to think about. Would T-Rex have hunted and eaten Diplodocus? We've got some things over here that might be useful to join in today's lesson if you fancy doing those things. Otherwise, if you sat around thinking, what should I do? Feel free to like and subscribe. Feel free to go over to Facebook. If you have Facebook, give me a little hi if you would like a hi back at the end. Feel free to write any reviews that come to mind. And feel free to join the maths mob. Any of those things. You can find the free workbooks on my website. It does look like the same workbook as before. I've just updated it to have the extra pages because it felt like it was getting to a lot of printing when I was doing different workbooks for every session. It was getting a bit excessive maybe. All right, I'll be with you very soon. I'm nearly there. I just have to light my incense stick so I know where I'm at. We're on a rosemary and Palo Santo one today. In case you're interested. A little smoky number, so I'm going to have my window open. There's a little post on Facebook that says, Maths in Dinosaur, timelines, comment here. I noticed last week there was comments in a few different areas. That's the one I'm going to be checking. Go for that one, yeah? Oh, my tea's a bit hot still. Okay, we're about there. Okay, good morning, Maths Mom! It is morning, just still. Hello. I'm Ruth. This is Joyful Maths with Ruth. This is my all ages maths lesson. And yes, I do mean all ages. You can join no matter what your age. I'm going to try and make this as accessible and enjoyable as possible while still having some really deep, complicated thoughts around maths and solving problems. Okay, so this term we're looking at maths in dinosaurs, chosen by you. You asked me a load of questions that I said I would answer using maths. That was naive of me because that was quite hard. I have still done it. Don't you panic. I've still done it. Today we are looking at timelines. The first question I asked you in the something to think about, would T-Rex have eaten Diplodocus? So just to give you a little bit of background here, I mean, this is absolutely not a T-Rex or what a T-Rex looked like, but massive carnivore, definitely apex predator, carnivore, so it ate meat, hunted. There's definitely teeth marks in bones that we know. We definitely know that it ate other dinosaurs, 100%. Diplodocus, the scale is dire here. So like Diplodocus would have been massive in comparison. Much bigger dinosaur, but herbivore, like a cow, only ate things like leaves and grass, but absolutely ginormous. Very slow moving. Lots of meat on its body. Weighed a lot. What do we reckon? Do we reckon that? Oh, sorry, that's my monkey. Would the T-Rex have hunted and eaten Diplodocus? I'm going to give you a little clue here. Have a little look at this. I'll talk you through the clue a little bit. Okay. So this is my little clue. It's what we're focusing in on today. This is a timeline. The Mesozoic era is when most dinosaurs were mostly around. Okay, so there's a bit of disagreement about how quickly or slowly most dinosaurs, non-avian dinosaurs, died out after the Mesozoic era, and obviously there was sort of like years and years of millions of years of evolution for dinosaurs to come around. But this is when dinosaurs ruled the earth, shall we say. So it works backwards, this timeline, so humans are off to the right hand side somewhere. Humans came around to the right hand side, and as we go backwards, the Cretaceous period was about 65 million years ago. The Jurassic period the Cretaceous period ended 65 million years ago, and it started around 144 million years ago, which is the end of the Jurassic period, which started around 213 million years ago, which was the end of the Triassic period, which started around 248 million years ago. And the Mesozoic era spans all of that, when dinosaurs were alive. And I asked you, what do you think about T-Rex eating Diplodocus? It seems logical, right? Doesn't it? Massive dinosaur full of meat, apex predator comes along, jobs are good. And I have a love-hate relationship with the way my brain works, but yeah, jobs are good, and let's go with that for today. But there's an issue here, and some of you may have thought of this issue. Diplodocus and T-Rex did not exist on this earth alive at the same time as each other. Diplodocus was around in the Jurassic period, nearer to the end of the Jurassic period, whereas Tyrannosaurus Rex did not evolve into being until towards the end of the Cretaceous period. So you just wouldn't have ever got a live Tyrannosaurus meeting a live Diplodocus at any point. These time periods lasted for millions and millions of years. It's not like a lion coming across a cow. It would be like actually a lion coming across a Diplodocus. It would be more like that sort of realisticness of that happening. I'm having some right funky times with my what are you on? Camera, my webcam today. It's going all over the place. Okay, so we want to represent this. We want to represent these sorts of things fairly accurately. We want to have a good idea of where things lie on timelines. That can help us with problems like this, working out when different dinosaurs lived, what would eat what the food webs and things like that looked like at that time. So it's really helpful for us to be able to lay this out in a relatively accurate way. So I'm going to show you that timeline again, and I'm going to pose you a question. What would you need to know, or what would we need to work out in order to be able to present this information a little more accurately? I'll say that again. I was going to try and rephrase it, but I can't think of the way to say it. What would we need to know, or what could we work out in order to present this information a little bit more accurately? I'll let you have a little think on that. Whilst I have a little sip of tea. do you reckon? So I asked this question. Obviously, you guys can't. I don't have comments on YouTube, so it's a different experience to Facebook because some people like comments, some people don't. So on Tuesday on Facebook, when I asked this, people said we need to work out how long each of these periods lasted. Spot on. You are right. We need to know how long each of these periods lasted. Was the Cretaceous period and the Jurassic period and the Triassic period all the same length of time as each other? And how long ago did they happen from now? What was the distance in terms of time? What was the difference in terms of time from now back to the end of the Cretaceous period, like the mass extinction, when we know that all non-avian dinosaurs died out? Okay, so before we start doing that, I was really hoping on Facebook there would be this seamless what's the transition between me asking that question, somebody saying something along the lines of, well, we would represent every year with a centimetre, maybe. It didn't happen. So I've had to say, like, what if we represented every year with 1 centimetre? Because that would be a way to do it, wouldn't it? If you wanted to be super accurate, you take a measurement that represents a period of time and keep repeating it over and over again. So what does, I want to picture what 1 centimetre representing 1 year would look like if we want to look at millions of years, because humans are notoriously awful. In fact, not just humans, all animals are notoriously awful at looking or representing large numbers. I'm reading a book at the moment. Actually, humans didn't have words for numbers above 3 or 4 for a very long time because there was no need for it. 1, 2, 3. Wow, there's a lot. That was enough for hunter-gatherers, for example. So 1 million is quite mind-blowing. It's quite hard to get your head around. So I thought, let's take 1 million centimetres and think about how far that actually is. Because visualising 1 million centimetres is really, really hard. So 1 million centimetres. This is where I've put my board. Here we go. Let me grab it. Let me grab my trusty board. Okay, so glare is not my friend. So if you've got a calculator, this could be helpful to you. 1 million centimetres is 1 with 6 zeros after it, like this. So that's 1 million. We're going for centimetres. Oh dear. I told you I was having a funky time with my camera today, didn't I? It's like, maybe that's been the problem. The leg's been wonky. Okay, that explains it. Right, there we go. Solve the problem. Never mind, that never happened. You're back now. Be in the classroom. So let's turn that into something that we can visualize maybe a little bit easier. Let's go to meters. Some of you might know how many centimeters are in a meter. Some of you might not. I'm going to tell you, for 1 meter, you get 100 centimeters. So to see how many meters are in this, we're going to divide by 100. You can pop that into your calculator. 1 million divided by 100 and see what that gives you. And hopefully it should give you 1 with 4 zeros after it. 1, 2, 3, 4, which is 10,000. 10,000 meters. Well, that's still a massive number. Humans rubbish at visualizing what 10,000 actually look like. So let's go to an even bigger unit, which is kilometers. So kilometers, you might think about traveling in the car when you're talking about kilometers. So let's go to kilometers. And with kilometers, some of you may know this, some of you may not. How many meters in 1 kilometer? Well, kilo. Centi actually means 100th, which is why we divide by 100. Kilo represents 1,000. So it's actually 1,000 meters in a kilometer. So we want to divide this by 1,000 now. So 10,000 divided by 1,000. Again, you can pop that into your calculator if you want to, or some of you may know that actually represents 10. So if I was representing 1 million years using the scale 1 centimeter equals 1 year, I would actually need a timeline that is 10 kilometers long. 10 kilometers for 1 million years. Well, that for me is like going all the way to the next village and back again 10 kilometers. So not very realistic that we're going to have a timeline that is that long. I'm also going to do it in seconds as well, but it just felt too much calculation in one go. But if you want to have a go at that, turning seconds, 1 million seconds into the number of days, that's quite a fun thing to do as well. I'll let you do that at home then. You can always email me if you want to email me with answers and stuff. I'm more than happy to look at them or post on a social media page. So if we look at this, if we wanted to go to 65 million years ago, we would need to do 650 kilometers. 650 kilometers. That is, what is that in miles? Like, it's over, it's more than like 300, between 300 and 400 miles. So really, like, it's a good distance. I'm trying to think between two places, maybe Newcastle to London, maybe even further than that, just to represent the first 65 million years. And then we've got all of these sections to represent as well. So we're not going to be able to be that accurate today. I just don't have anything that's quite that big to do it on. So what we're going to do instead, we're going to use parts of our body to estimate. So our body is quite proportional. If you study lots of different people, you find different parts of their body actually fit in places in similar sorts of ways. So for most people, you can have a go at this yourself. For most people, if you are flexible enough and you can put your foot on your arm, put in your toe at your wrist, your heel will meet your elbow joint. For most people, that is roughly correct. So we're going to use parts of it. We're going to use our hand to represent this distance instead. Okay, so we're going to use our hand. That's going to represent that 65 million years from when humans existed to when dinosaurs were wiped out, when non-avian dinosaurs were wiped out. We're going to do a little timeline along our arm. Now, this is a little bit of a cop-out here. I am going to draw on my arm. I'm going to use a whiteboard pen. I learnt, because the first time when I was practicing this, I did it in permanent marker and it lasted for quite a few days. I'm doing it a whiteboard pen today because it washes off. I did say bring some Post-it notes with you because you may want to do it in Post-it notes so you're not writing straight onto your skin. It was just falling off a lot for me, which doesn't work for this, for me showing you what to do. Okay, so, you know, do what works for you, what's right for you. The other thing that people said that they needed to know were the gaps in between. So what were the lengths of period in between the different eras? So for the Cretaceous period, we needed to know what was the gap in time between the start and the end of the Cretaceous period. So we needed, when I asked on Facebook, I said, well, how are we going to work that out? What calculation are we going to do to find out this gap and this gap and this gap? People told me they're going to do a subtraction. We're going to take the larger number here, 144, and we're going to take away 65 to get this gap. Then we're going to do 213, take away 114 to get this gap, and so on. So I'm going to give you a second to do that, to work that out, to get those gaps, because we are going to need those gaps in a minute to draw our timeline along our arm. Again, feel free to use a calculator, feel free to do it without. Whatever suits you is absolutely fine by me too. We're trying to work out the length of time that passes in between these gaps here. I'll give you about, I don't know, I'm going to count to 20 in my head and then I'm going to show you what they were. Okay, so I make it out to be that these are the gaps. When we do 144, take away 65, we get 79 million years. That was the length of the Cretaceous period. 213, take away 144, gives us 69 million years for the length of the Jurassic period. And the Triassic, we did 248 to take away 213 to get 35 million years. So we can see here that we've got, this gap is definitely the biggest, isn't it? The Cretaceous. Jurassic, slightly less, ever so slightly, but not massively off. It's about 10 million years off. Whereas the Jurassic is about half the length, it lasted about half the length of time of the Triassic lasted about half the length of the Jurassic period, which is just under half the length of the Cretaceous period, okay? So how are we going to do that? How are we going to create our timeline? So I said, let's start with our hand. You'll have most people, I don't want to make assumptions, most people will have a left hand and a right hand. So I'm going to be doing this on my left arm. I'm going to create my timeline here. We're going to be moving backwards from the current day. The current day is going to be the tip of my middle finger. My hand is going to represent the distance between the current day and the mass extinction when dinosaurs were wiped out 65 million years ago. So that was the end of the Cretaceous period. And that was the mass extinction. So I'm putting a C there to represent the end of the Cretaceous period. So that was 65 million years ago. The start of the Cretaceous period was 79 million years ago. So in my making, a little bit further back than 65 million years ago. We're going to need a little bit of a bigger gap than our hand. So if we put our hand on there, I make it that we get, if we went to the, would you say to the elbow joint? That would be fair. Because if I put my hand there, my elbow joint is a little bit further away, isn't it? A little bit further away. So if we went to our elbow joint, that could be the start of our Cretaceous period, but the end of the Jurassic period. The end of the Jurassic period. So my Cretaceous period is here. This is our mass extinction. This is present day, right at the end here. Start of the Jurassic period. The Jurassic period, you might remember, lasted about 69 million years. Well, it's 65 million years since most dinosaurs were wiped out. So that's roughly about the same again. So we're going to need about one hand span going back, which takes you to just before, on my arm, just before my shoulder here. So just before my shoulder, we've got the start of the Jurassic period, which means just before that, I have my Jurassic period. And as discussed before, the Jurassic period was about half the length of the Jurassic period. So if I look at my hand, my fingers start about halfway along my hand. So if I do a finger span here, that takes me just up to my shoulder here. So I'm going to put that on there, and we've got the start of the Jurassic period. Okay, so that gives you quite a good visual. Like if we think, this is how long it's been since dinosaurs were wiped out, this bit here. I need to really hold my arm right out straight. Look at just the length of the Cretaceous period itself. How much longer that lasted than since the extinction of dinosaurs. Then we've got the Jurassic period and the Triassic period as well. And my next question to you is that humans evolved. So they didn't just appear. It wasn't like an ape gave birth to a human one day. There was like slow, or as I've mistakenly given the impression sometimes, an ape was born and turned into a human as they lived. There's like small incremental changes where humans slowly evolved from apes over millions of years. But they reckon the first humans walked on Earth around 200,000 years ago. Around 200,000 years ago. We want to pop that on this timeline somewhere. So 200,000 years ago. Have a little think about that. Whereabouts would you pop this on your timeline? Have a little think about where that might lie on your timeline. Whereabouts would you think of putting that? So 200,000 years ago. It's not even a million years ago. Not even 1 million years ago. So a hand is representing 65 million years. So if I wanted to represent a million years, I'd need to chop it up into 65 equal sections to represent a million years. Well, 200,000 isn't even a million. In fact, if I want to work out what fraction it is of a million, I'd need to write it as a fraction over a million. So 200,000 over 1 million. 2, 3, 4, 5, 6. And I can keep dividing by 10, divide by 10, divide by 10, and so on, until I end up with 2 over 10. 2 over 10 is our fraction, which is the same. It means the same as a fifth. So it's only a fifth of a million years. Only 1/5 of 1 million years. So if I was to look at my hands, and split it up into tiny little sections that represent 1,000,000 years. So I'd need to split it up into 65 sections. And maybe I end up with this fingertip here. And that represents about 1,000,000 years. I'd need to split this fingertip up into 5 little sections. And just right at the end, in that last 5th section, that would be when humans evolved. Just right at the tiny end of that fingertip would be where humans evolved along this timeline. I think it's absolutely mind-blowing when you look at it like that. Think about how many times that's going to fit into this entire timeline. It gives you a good idea of why Diplodocus wouldn't have met Tyrannosaurus Rex, who would have been here, Diplodocus somewhere down here. Gives you a really good idea. Now, all of this lesson was inspired by one question, which was this. I'll show you the question. Would Giganotosaurus have been eaten by anything? Would Giganotosaurus have been eaten by anything? So I looked at, like, if you were asked that question now, what would you start looking up? What sort of things do you need to know? And what sort of things might you need to work out in order to answer this question? That's your mathematical thinking for you. Mathematical thinking tends to go, what do we know? What do we need to know? And what do we need to work out? So Giganotosaurus, some of you will be like aware of what this animal was. Some of you won't. Some of you will need some facts. So I looked them up for you. I like doing this. It's a bit like top trumps. So some of the facts that I found about Giganotosaurus. You may have been saying, well, I need to know what type of dinosaur it was. It was, in fact, a huge predator. You might notice this looks exactly the same picture as the one I used for T-Rex, and you would be right. It is, because trying to find separate pictures for the two was quite challenging. It was a huge predator. Its length from tip of its tail to its nose was around 12.6 meters long. An estimation of its mass, so how much it would have weighed, was about 7.8 tons. So that's like 7 lots of my car. I do drive a very small car, mind. And its top speed, they estimated to be about 24 miles per hour. So pretty speedy for a dinosaur. The other thing people ask me is, when did it live? When was Giganotosaurus roaming around alive on this earth? And it was roaming around on the earth in the late Cretaceous period. That's when Giganotosaurus was around. So what else would you want to know in order to answer this question, and what would you want to work out? So I'll turn it around so you can see the facts again. What other things might you want to know and might you want to work out? Now, I'm going to be honest, this was seamless on Facebook. It really was. It was like I wrote it, like I placed someone there to ask the questions for me, but I didn't. Because straight away, somebody noticed something about this Cretaceous period. And they wanted to know, was Giganotosaurus an apex predator of its time? And how did it compare to the Tyrannosaurus Rex? Very good question. So apex predator would be like a top predator. Nothing else would hunt it or try to kill it. Okay, so it'd be like top of the, I mean, food chains are too simple, but if it was a food chain, it would be the last thing in the food chain. Nothing else is going to hunt that animal and eat it. And as it happens, I thought very similarly. I was like, yes, Tyrannosaurus Rex, we saw earlier, was also around in the late Cretaceous period. It was a massive predator. So how would these two animals size up against each other? So we've got a bit of a dino battle for you. Who do you think would win? Who do you think would win out of Giganotosaurus and T-Rex? I'll give you the stats. So length. We've got the length of Giganotosaurus. It's 12.6 meters. Length of T-Rex, 12.5 meters. The mass They estimate the mass of the Giganotosaurus to be 7.8 tons. The mass of the mighty T-Rex, they estimate to be nearly 2 tons more, 9.6. And their top speed, they estimate to be roughly the same for both. So which one would you say is more likely to win? Which is going to be your top trump? So in most of these, the length, very similar, aren't they? Very similar in terms of length. Very similar in terms of speed, but mass, that T-Rex looks like it's going to be a big old dinosaur in comparison. It's going to have brute force potentially on its side. And the other bit about the T-Rex was its incredible bite force, how much it could bite down. So if we think about crocodiles nowadays are known for being able to bite, have such strong jaws, they can bring them down really quickly and have a huge amount of force. So it's really hard to open them up again. The T-Rex, that bite force, they estimate to be between 35,000 and 56,000 newtons. So I wanted to give you an idea of what that might look like. Some of you may have done this, some of you may not. You do not need to open this. If you bought a bag of sugar with you, or I couldn't find a bag of sugar, I had a bag of flour that we hadn't opened yet because I didn't want to bring an open bag. The roughly weighs a kilogram. We're going to use that to give us an estimate. So you might want to feel how much it weighs. Like, I don't know if it's as heavy as you expect it to be, but it's a good idea to get hold of. Okay. Now, if you brought a tape measure, the next thing I'd like you to do is get your tape measure and we're going to extend it out to a meter, which is 100 centimeters. And give yourself a rough estimate. We're going to measure out on your floor about a meter square. Okay, so if I move my chair out of the way, let's see what this looks like. I have to just for a second. A meter square. What's that going to look like? So, where's my tape measure gone? We're going to go across a meter like this. Yeah, so it's about the width I've got here. And then across a meter like that and create like a square shape. You might want to just have a good visual for what that square is going to look like. There's my square, like that. Okay, so for 1 Newton, we would take this bag of sugar or flour, whatever you've got, and spread it into that square. Don't do it unless you're happy to glue it up afterwards, I suppose. But you can imagine that doesn't seem like a huge force. But if we took this and then got 35,000 of them and piled those up inside this square, like all on top of each other, I don't think I could even fit that into this room. And that is the sort of force that is going to be coming down, or they reckon a T-Rex could chomp down with. So it's got an incredible bite force. So that works in favour of the T-Rex for sure. However, there is one thing that I found super disappointing, because these two, actually, despite both being around in the late Cretaceous period, it's very unlikely a Giganotosaurus and a T-Rex ever met, because of this massive timescale we were working with. Giganotosaurus was around 98 million years ago, whereas T-Rex, it was more like 68 to 66 million years ago. So if we go back to our timelines on our arm, so if you hold out your arm, we had 65 million years ago, which is the end of the Cretaceous period. So T-Rex was around about that sort of time. Whereas Giganotosaurus was 98 million years ago. Well, this was 144 million years ago. We're sort of coming halfway along here. So there was quite a gap between these dinosaurs existing. It's unlikely they were alive at the same point as each other. and also unlikely that they lived in the same area as each other. So it is likely that the Giganotosaurus was an apex predator and nothing else was likely to hunt it in the time. However, I'm going to put the question up again with a little picture. Just have a little think about, because I reckon there might be another answer to this question. What do you reckon? I think there might be another answer to this question. Would Giganotosaurus have been eaten by anything? Anything. And this is the clue to what I was thinking. Here. This is a picture of a hyena. So would Giganotosaurus have been eaten by anything? What do you reckon? What do you think? Because I think even lions are eaten by something. They maybe aren't hunted. They may be apex predators. But when lions die out, you don't go around Africa and find just lion bodies everywhere. They get they biodegrade. Is that the right word? They decompose. They decompose, don't they? So either they're eaten by bugs and insects and other, what's the word? Microorganisms. That right word? I think that's the one I'm looking for. Or things like hyenas are going to come along and scavenge that food and eat it up. So there is evidence to show that dinosaurs were scavengers. They didn't just hunt. That the meat-eating dinosaurs were scavengers as much as they were hunters. So I suspect Giganotosaurus was eaten by something, but not necessarily hunted by other animals. Okay, we're going to end on a quiz. We've got 3 questions here. 3 questions, and you can do it however you want. If you've got the workbook, you're welcome to do it in the workbook. You're welcome to shout it out, and I'll try my best to listen for your answers. Or you could just think it. You could just think whatever you want, and that's okay too. Okay, are you ready? So the first question: can you put these in order from the latest? So what came first to what came second to what came third? So we've got the Cretaceous period, the Triassic period, and the Jurassic period. Can you put them in order? Can you put them in order? Okay. Second question. What fraction of 1 million years ago did humans evolve? 1/5, 1/4, 1/2. And this is my clue. It was 200,000 years ago. 200,000 years ago. Okay, third question. What is 1 Newton? Is it equivalent to 1,000 bags of sugar in 1 square meter? 100 bags of sugar in 1 square meter? Or 1 bag of sugar in 1 square meter? Okay, let's have a look then. So I think I heard some shouts. In there. Maybe just from downstairs in my living room. But I think I heard some shouting. So the first one, if we want to put them in order from what came first to what came last, we just go along our timeline. Jurassic period came first, then the Jurassic period, and then the Cretaceous period, which lasted the longest. What fraction of a million years ago did humans evolve? It was right at the pinky at the end of our finger. If that represented a million years, this was 1/5 of that. 1/5 of a million years ago is when humans evolved. And 1 Newton, where's my bag of flour? 1 Newton was the equivalent of 1 bag of sugar or 1 bag of flour in a square meter. That's equivalent of 1 Newton. That is the end of today's lesson. Thank you so much for joining me. It has been absolutely epic being live with you this week. I have very much enjoyed it. So I am going to say some highs. If you want to say hi on Facebook, if you want to say hi to me and have me say hi back, please do go onto Facebook. There's like a little space for you to comment. The picture is the one with a dinosaur on it. That's the place to comment and say hi if you want to. Whilst you are having the opportunity to do that, don't worry if you can't. If you've not got Facebook, no problem. Hi to you anyway. I'm just going to give you my little spiel about how I get paid. So I do these lessons for free, totally inspired by the epic legend that is Lara from Theatre of Science. And this is to the homemade community, to support the homemade community, which I am part of. But also, this is my job. It's a major part of my job, and how I get paid is that people that can afford to do so sign up for £5 or £6 a month. And to them, I send a thank you, which currently is my Fractals activity book. I am beavering away in the background on my weather one. It is slow progress because I've just had so much to do the last couple of weeks, but I'm hoping to get that out there in the next few weeks. So this is my Fractivities one. This is all about fractals, an area of maths you just don't hear about in schools, which is such a shame because it's so cool. Lots of hands-on ways to explore it, and games and engineering activities in there. That comes out with some really cool, funky origami paper and some funky stickers that I've designed as well. And yeah, so those, when you sign up, the money is going towards my wage, which is mostly planning and delivering these lessons, not the workbooks. They're just like a little thank you on the side. Right, I'll go and say hi to people that have been on Facebook now. So yeah, if that's you, stick around. Let's see who we've got. I'll do one refresh at the end as well because it's important. It's important stuff. Right, if I put newest first at the top, I think that works. Okay, so, Freddie will be joining. Hi, Freddie. Nice to have you here. Who else have we got? Margaret, I think it is, says hi. It says Margaret is the name. So I'm going to hope it's Margaret. Hi, Margaret. Nice to have you with us. And hi from Brandon. Hi, Brandon. Nice to have you here today too. Hey, right. I think I'm saying this right because I've taught someone with the spelling before. Have, I think it is. Have is ready and waiting. Woo! Nice to have you here. The live chat one. Yeah, you do. If you want the live chat one, Tuesdays, come and join in on Tuesday for sure. Connor, loving the dino lessons. You're a dino nerd. Yes to dino nerds. In fact, yes to any nerds. I'm going to be honest. Nerds are my people. just anything. If you geek out about anything, it's really cool. I just think it's awesome to like just really have a passion and love it. Nice to have you here, Connor. Are we in the right place? I think you were in the right place. I hope so. Maybe you were on Facebook. Today was on YouTube. I put the link underneath on the advert on the day. So, or all else fails, go to my events and you'll be able to click from there. Always go to the events if all else fails. Isla and Rona say hi. It's your first home ed half term. Isla and Rona, I hope it is the best for you. So good that you're here with us. Who else have we got? Hi from Sophie, Emily, Katie, and Hannah. You made it live this week. Woohoo! Yeah! You missed last week because you were swimming in the sea and enjoying the sun. I cannot blame you. If I have the option to swim in the sea, I will always take it. I love it. Obviously, other than being here with you guys, because I love being here with you guys more. So, yeah, maybe I'd have made a slightly different choice to you, but I'm cool with that. I'm cool with that. Go and swim in the sea, definitely. Make the most of it. Oh, you guys are late. Nicola, you were late, but hi anyway, and that is fine. And you got Triassic, Jurassic, Cretaceous. Perfect. Ace to have you here. Effie! Hi, Effie! Nice to have you here too. Hi from Archer. Hi, Archer. I think, was Archer with us earlier as well? Did I say hi to you earlier? Or am I getting confused with someone? I think I said hi to you earlier too. Awesome. Double maths day. Yes. Yes. Unless I got that wrong, in which case, single maths day. Yes. Awesome. Hi, Bella. Your favourite fact about timelines is that a T-Rex and Triceratops would never have met. Yeah, Triceratops wouldn't have ever met a T-Rex either. I think, am I right, Bella? Correct me if I'm wrong. Triceratops were around Diplodocus time as well, so they wouldn't have met. I mean, it's sad because they're both cool dinosaurs, but it's also cool, isn't it? The fact that they were just like they were probably fossils before T-Rex even existed. Like, get your brain around that. A Diplodocus was probably already a fossil before T-Rex came onto the earth. Brain. That's how I feel. Hi, Aurelia. Nice to have you here too, Aurelia. Bye. Bye, Nicola. Nice to have you here. Right, I'll do one more update. It's nice when people say hi and bye. That's really polite and lovely. And like, you just don't get that digitally nowadays, do you? Like, digital politeness. Oh, makes me feel good. Oh, hi, Imogen and Lady the cat. Oh, you know what? It's a day for cats because I had cats in my other lesson earlier as well. Shall I just show you Lady the cat? Look. Very gorgeous. All white as well. Very beautiful. Hello, Lady. Thank you for being with us. I appreciate it. Thanks for putting me in the vid. You're more than welcome. It's nice to say hello to you. Thank you for being in the video. And then I saw, yay, yeah, I was right, Archer, double maths. Whoop, awesome. You guys are epic. Oh, thank you so much for joining me. If you do like the live comments ones, Tuesday is your place. We have live comments always on Facebook. This one's at 9 o'clock, and then I do the GCSE one at 10 o'clock. Otherwise, I'll be back here this time next week. I think doing the loudest dinosaur. I think it's the loudest one next week, which could be fun, couldn't it? So hopefully I will see you then. But it's bye for now for me, and thank you so much for joining, guys. Bye. Ooh. My thing fell off.